Good evening to everyone. Today we are going to discuss part B problem in the real analysis in the year December 2019 question paper. Okay, only one problem. So problem number 1. Let less than or equal to be the usual order on the field K of real numbers. Define an order define this like that on R2 by a comma b is less than or equal to c comma d if order defined like that if a less than c and or a equal to c and b less than or equal to d. Consider the subset e equal to set of 1 by n comma 1 minus 1 by n belongs to R2. N is the belongs to the positive integer, that is natural number. With respect to the order defined less than or equal to, which of the following statement is true? Okay, which of the following statement is true? It's a very simple problem. So infimum of e here defined 0 comma 1. Options are, and supremum of e equal to 0 comma 1. And the second option, infimum of e does not exist, but the supremum of e 1 comma 0. Option 3, infimum of e 0 comma 1, but the supremum of e does not exist. Option 4, both infimum of e and the supremum of e does not exist. Okay, it's a very simple problem. First of all, the order pair define, how to define the order pair a comma b is less than or equal to presect சொல்லுவாங்க. It's a c comma d. How to define the order define பண்ணிருக்காங்கன்னா, that is a less than c, the first element should be less than, or the first elements equal and second element should be less than or equal to d. That's the idea. Okay, so when you define like that, the given order like that, order on R2 defined like that, a comma b is less than or equal to c comma d if a should be less than c or a equal to c and b less than or equal to d. Okay, so the given subset is e equal to set of 1 by n comma 1 minus 1 by n. The n is belongs to natural number. When you expand this set, this is n equal to 1. We get the 1 minus, this is 1 by 1. It's a 1 minus 1, 0. When you take the n equal to 2, 1 by 2, 1 minus 1 by 2, it's a 1 by 2. 1 by 2, comma 1 by 2. When you take n equal to 3, 1 by 3, comma 2 by 3. Okay, where here 1 by 3, 1 minus 1 by 3 is a 2 by 3. This is and so on. This is the actual subset. The actual subset is the e equal to 1 comma 0, 1 by 2 comma 1 by 2, 1 by 3 comma 2 by 3, and then when you take the n equal to 4, 1 by 4 comma 1 minus 1 by 4, 1 by 4 means 4 minus 1, 3 by 4. Okay, so 1 by 4 comma 3 by 4. Okay, so how to find the supremum and infimum? To find the supremum of e, okay, actually define the order a comma b, c comma d, a less than c or a equal to c and b less than equal to d. It's a very important. This is the only concept, this one. Okay, so here define. So consider the set. I will take the first element only. First order pair in the set, only I will consider the first element for find out the supremum of e. So 1, 1 by 2, 1 by 3 and so on. What are the supremum for this one? What are the supremum for this one? This is the 1 by n. Okay, so as n tends to infinity, it's become the 0. It approaches to 0. Okay, so the supremum is here 1, and what about the infimum? Infimum is 0. Infimum is 0 because of 1 by 1, 1 by 2, 1 by 3, 1 by 4 and so on. It approaches to 0. As n tends to infinity, this is 0. So infimum is 0, supremum is 1 here. Okay, that's all. So for every a comma b in the set E, a is less than or equal to 1. A is less than. Why a is less than or equal to 1? Here supremum of the first element is 1. Supremum of the first element is 1 now. For every element of a comma b in the set E, a is should be less than or equal to 1. This is the idea. A is less than or equal to 1. Not less than. It's a strictly less than 1. Okay, a is less than 1. A is less than 1. Okay, a is less than 1 means a comma b order with 1 comma 0. because of a is strictly less than 1. By the definition, the order defined like that, a less than c or a equal to c and b less than equal to d. C. Here a is less than 1. A is less than 1 because of 1 is the supremum of the first elements of the set. So that a is less than 1. So that a comma b order with 1 comma 0. So that means what is the conclusion for every element of the a comma b in the set E? This is the 1 comma 0 is the supremum. The supremum of E is 1 comma 0. The same way, what is the infimum here? 0. Infimum here 0. So we can write down 0 less than a. 0 less than a. 0 less than a means 0 less than or equal to a. Okay, 0 less than or equal to a means, so for every element 0 comma 1, okay, so how to choose the 1? So that I'll to find the infimum of E, so I'll take the second element of the set, 0, 1 by 2, 2 by 3, 3 by 4 and so on. So what about the infimum for this one? Infimum is 0. So the structure is n by n plus 1, n by n plus 1 structure. So what is the its approaches to? Its approaches to 1. N by n plus 1, as n tends infinity, its approaches to 1. Okay, so infimum is 0, supremum is 1 here. So that for every a comma b belongs to E, 0 is less than a. 0 is less than a. 0 is less than a means 0 comma 1 is ordered with a comma b because of 0 is less than a. So it satisfies the first condition. So that it's an infimum here for every element of a comma b, 0 comma 1 less than or equal to a comma b means infimum of E equal to 0 comma 1. So therefore from this, what is the conclusion? Infimum of E equal to 0 comma 1 and supremum of E equal to 1 comma 0. So therefore its option is, okay, option is first one is correct. Infimum of E equal to 0 comma 1, supremum of E equal to 1 comma 0. It's a mistakable one. So inga 1 comma 0 varum. It's a change it. It's a 1 comma 0. So infimum of E equal to 0 comma 1, supremum of E equal to 0 comma 1 is the correct option. So option 1 is correct. Okay, idu konja wrong type pannita. It's a 1 comma 0. Okay, thank you.